Hey everyone, welcome back. We are back in the lab today and I've got something special. It's demo day. I want to show you guys. So what you're seeing here is what I'm calling right now CCIE Brain. This is a AI networking agent that operates at, I guess, a CCIE or senior level. And it is connected to a live spine and leaf fabric that's running 10 devices across 2 vendors. We've got FRR and Nokia SR Linux. And so, and there are 2 different autonomous systems. One's in autonomous system in AS65000, the other's in AS65100. So, like I said, this is my agent, and the agent, thinks and operates by using what we call an OODA loop. That stands for observe, orient, decide, and then act. And if you follow along here with my guide here now, I want to just make note that Claude helped me create this graphic that you're seeing here that we can follow along. So, I use Claude in my workflow, and that's something that I'll probably have some more videos coming out on later, but I just wanted to call out that these graphics that you're gonna see on this demo were all done with the help of Claude. So, so the loop, we start with the observe phase, and the first thing that the agent is going to do is observe the network that it's built in. So it's going to SSH into devices. It's going to collect live protocol states such as OSPF neighbors, BGP summaries, interface status, raw data, things like that. Then it's going to orient itself, and it does that by searching basically a corpus or a document knowledge base of 50 or over 50 documents, I believe I have. They consist of OSPF troubleshooting guides, BGP best practices, different vendor caveats, because FRR is different than SR Linux, so we have different caveats in for each OS there, and it also uses a hybrid retrieval method. So the way it kind of works is we do a vector search plus BM25. I'm not going to get into all that here and what that does, and then we're going to fuse it and then re-rank all of the data and the queries that it gets. So this is what gives the agent its context that a senior type engineer would kind of carry around in their head. And so then what the agent then does is it takes that evidence and the information that it's going to gather from the observe and the orient phase, and then it's going to use that information to identify a root cause, and then it's going to create a score based on its own confidence of how accurately it thinks it has solved our problem. And the good thing about the agent is if the confidence is too low, it'll go back to the observe phase to try and collect more data instead of guessing. And if it's not able to come up with a guess, it will let you if it does not have enough information. And then finally, we move on to the act phase where the agent is going to propose a fix. And it's in this phase, though, that we've instituted the human in the loop, where the human, me, whoever the engineer that's using the agent, will have to approve or reject the decision that the agent gives us. So, and once you approve it, you see the exact commands that the agent has run and the reasoning behind it, and it's up to you to then decide whether or not you want to accept the agent's reasoning there. So let's talk a little bit about the data flow and how or the architecture and how the data flows in the system. If you start on the left, like I said, this is where our knowledge base starts, or where our knowledge base lives. So OSPF, BGP, ISIS, SC. Think all the things that we as network engineers learned. This is stored inside of Chroma DB. So when a problem comes in, the retrieval engine basically decomposes the query that we have, and it runs, like I said, the vector and a BM25 search in parallel, and basically fuses it with a reciprocal rank refusion. Now, all this stuff, it might sound complicated and whatnot, but like I said, basically it takes the information that it searches for. It matches the information up with the information that we've already given it that we've pre-stored. It mixes it all up and decides which are the most relevant chunks, and then it presents it to us. So That context, like I said, it feeds into Claude, and that's, based on that, then Claude's able to decide on which tool it's going to call. Now, with Claude, the tool layer here, we've got 3 different trust tiers, okay? So we use MCP, and the security is basically enforced before Claude's able to do anything, before any kind of execution there. So, and I'll get into that a little bit more as we go down, but security is baked into the forefront of this whole thing. So, and then finally, like I said, once we get to that tool that tool layer, then it goes directly to the devices, and we're able to pull information from our devices there. So now if you're looking here in the middle, this is, like I said, my fabric inventory, where we have, my FRR network here consisting of 6 devices, and then we also have my SR Linux network here consisting of my 4 devices. And it shows what we're running in each network, how many BGP peers. We're all running all peer-to-peer. We got peer-to-peer links here, and we've got BGP running in here. And then we're pulling information from the SR Linux using JSON RPE, the API. That's not on FRR right now, at least that I have found. So we're just doing straight SSH using Scraply. But that's kind of how we're pulling the information from the networks. And then lastly, let's go to the security part. For me, this is my framework, which I've called the structured network autonomy. And basically what this is, it's like I said, it's the trust tier. So we've set it up where the agent itself has autonomy to do things such as read commands, like get a health check, and send show commands. Send show commands. Do things like, anything that's basically a typical show command that doesn't require a config change or anything like that, or any type of health check. I've given the agent full autonomy to do that when we query it. It's not going to ask us, hey, is it okay if I go and check the routing table on, leaf 1? It's going to just go ahead and do it. Now, we also have the supervised analysis phase and analysis tool. Now, what this is this basically is things like your config drift and your drift detection. And if the agent notices that there's some drift in your configs, it's going to alert us to go in and verify that and make sure that that drift is intended before it gives us a recommendation on any kind of fixes that we might see for whatever alert it gives us. And then we have the last phase, which is the approval required phase, and this is for write tools. So anything like your send commands, if you need to remediate an interface, like bounce an interface, if you're going to modify routing tables or anything like that that requires you to actually change the configuration on a device, that's going to require human approval no matter what. And then lastly, everything here is in our gate audit. And I want to send a quick shout out to John Capobianco. He's the one that, great engineer that basically he created Gate. And Gate is kind of like a Git style audit trail for AI agents. So what that's going to allow us to do is track every single thing that the agent does and every conversation that we have with the agent. So whether the agent was successful, whether the agent fails, we're able to track it and see it all in an immutable audit trail and logs there. So that's kind of like a very, very high level of what's working within the agent. I might do some more deep dives later, I don't know, about what's actually running under the hood. But with that said, and now that we kind of know what the architecture is, let me show you what it's like to use the agent and watch it run in real time. If you've been looking here on the right side of the screen, this is my agent's dashboard. Everything in my network is running completely fine now. So we have no alerts, and this is the application for my agent is housed in my Kubernetes cluster. So we have our remote ChromaDB database here. That's where all of our knowledge base is, our corpus. We have all our secrets, so our API keys for Anthropic, our API key for Netbox, because Netbox is the source of truth for my network, which the agent is able to call as well to, that's how he makes sure his drift detection is on point, because he's able to access Netbox. So that API is in the vault. As you see, we've got the gate audit here, located at this address, and it's writable, it's true, it's initialized, it's good to go. And we SSH into our devices, that's good, they're all reachable. And then we have a monitor that's been running here, and the monitor is basically the agent looking for any kind of errors, and if so, it will give us an alert. So what I'm going to do is I'm going to use Claude to inject these, and I'm not going to show this part on camera, but and I'm going to talk to Claude to do this and inject some faults. And after I do this, we should see the agent go into action, and we should start seeing some alerts come in. So let's see what we can do here. And the first fault I'm going to do is I'm going to do a shutdown eBGP. And let me actually go to this screen so you guys can follow along now. So these are the scenarios that we're going to be running. I'm going to do fault 1, we're going to kill the eBGP session. Fault 2, we're going to set up have someone like Fatfinger or the IP subnet address to give us an error there. And then we're going to do an OSPF timer mismatch, which is a little bit, well, you'll see. Let's just get into the demo, guys. So give me a second here. Let me bring up my terminal. Shut down the BGP neighbor 10.100.0.1 on leaf 3 to simulate a peering failure. Okay, now while this runs too, what I've used, guys, and this isn't, I'm not promoting anything, but if you aren't familiar with WhisperFlow AI, it's a great tool that I use. It allows you to just use your voice, text to speech, or talk to text, and it uses AI. It takes out all your ums. It's able to basically make sure it captures the essence of what you're speaking. So I just wanted to throw that in there. If you're not used to it, just Google it, Whisper AI, and it'll be good. All right, so give me just a second here. All right, so our fault has been injected, and we should see it pop up in a little while. So now, like I said, when we get ready to, or once the alert comes up, we should see an alert that'll give us access to go ahead and start that triage. It can take about a minute or so because my agent is doing polling every 60 seconds. So once an alert happens, it could be a full minute before the alert actually reaches the dashboard through a webhook. So, we'll just kind of sit here and watch. And if anything takes extremely long, I'll pause and come back because I'm doing this live. But we should be good to go. So let's just bear with it for another minute or two, and then we'll see if it recognizes the error here. All right, great, boom. So as we see here, we've got a BGP missing or neighbor missing error for our SRL border 1 device and our leaf 3. So between border 1 and leaf 3 here. So this eBGP peering is down. So what I can do, if I'm just getting this error, I can go directly here if I want to, and it ports the error message directly into my chatbot, so your interface, so you don't have to type it in yourself if you don't want, or talk it in. You can also go to the alerts and see the alerts and click on them there. It'll tell you that the BGP peer count is 3, which is below the expected 4, and the recommended action from the agent is to run the BGP troubleshooting tree that's inside our corpus base there. So if we go ahead and just click here, diagnose with agent, it's going to send you to the same screen, and then we hit send, and that's going to kick off our loop. So I'm going to go back here. Well, actually, let's go back here. So like I said, we're in the observe phase now. And the agent is going to SSH into our devices to gather the live state. So bear with it just a second while that works. Okay, so it's gone in, it's checked 10 devices, It's pulled 20 observations, and now it's about to orient itself. So it's going to orient itself around that knowledge base. It's going to vector and decompose our query, vector everything, and then re-rank it according to the most relevant information or the most relevant chunks. And then it's going to present it here for us and move on to the decide phase. So bear with me just a moment as it, well, actually, we'll go ahead and keep going because I want to talk about using Claude there. I have it set up where Claude can use, depending on the query that you give it, we have given Claude the agent the ability to choose which model Claude's going to use. Now for something like this that requires deep reasoning and going across multiple agents, it's going to use Opus. But for very simple requests, we've got the ability to use Haiku and Sonnet in there, and it does it dynamically. So like I said, that's another thing I'm not going to get into, but that has been built in. So now we can go ahead and see it's returned, it's decided with 95% confidence that the BGP peer for 10.100.0.0 is administratively shut on leaf 3, which is causing SRL border 1 to have only 3 BG peers instead of the 4. So as you can see here, it's made its determination. This text right here is basically a summary of what it did. If you want to see the full analysis, I've put that in there where it shows you the full analysis step by step so that you can see exactly what or how it came up with the information that it did and why it got the score that it presented you then. So now we're in the act phase. And as you see here, like I said, these show commands, they were executed because they're show commands. We've given the agent the ability to run those commands autonomously without needing our permission. But once it ran those commands and it got itself an answer, it's now up to the user to reject or approve the commands. And you can come in and see now it's going to say these are the commands that it's suggesting that we run. So we're going to basically SH or VTYSH into the device. It's going to go into the terminal. It's going to do a no neighbor shutdown and then bring it back up. And I'll go ahead and approve that. It's going to execute post change verification, shows you what it ran, okay? And now we can come back to our dashboard and we'll have to wait, like I said, because it could take a minute or so for the alerts to disappear. We have to wait for the alert to go. But while that's going, I'm going to go ahead and inject our second fault. So what I'm going to say is, all right. So change the IP address of spine 1 Ethernet 1 to 10.99.99.0/31 and remove the correct address of 10.0.1.0/31 to simulate a misconfiguration. Okay, so we've got that kicked off, but as we see, since that time, our alert has cleared. Everything is good to go. The eBGP session is back up. Now I can't show you that here because I don't have it on my, I'm not going to put it on my screen. My screen don't have enough real estate, but let's see here. Okay, so the second fault has been injected. So now I'm going to do the third fault as well, all right? Set the OSPF hello interval to 15 and dead interval to 60 on leaf 2, Ethernet 2, and create a timer mismatch with spine 2. Okay, so these are the tests. All the tests, as I show you, have been done. So we got a wrong subnet test and we've got our mismatch timer test. So as we see, here we go. The OSPF neighbor mismatch for the first one. And now, as you see, we don't know actually what the error is just by looking at this because the agent doesn't know. It just knows that something's off in the network. So, imagine you're in a NOC or you're, sitting at your desk and you're like, oh, why am I getting the OSPF neighbor missing on leaf 1? So now, like I said, you don't have to go either to the alerts. You can go right from here and just click on it. And then you can send that message and begin the loop again. So let's begin the loop. Let's see what Claude comes up with this time. Because it's warmed up, it should be a little bit faster as well. We'll see what the next course of action will be. Oh, one other thing. I do also want to point out that even though I'm using Claude, I have tested this out with local models, specifically Quinn models. I think Quinn.3, 30 AB. I've even tested it with, I believe, Llama 3, 8B. So I've tested it with several local models. Now, your mileage is going to vary depending on how well the model is, but the overall underlying system still works. You know, it's just going to be if your model is good enough to reason over something as big as a multi-vendor network. So that's another discussion for another day, but let's go ahead and see here. We've got the next one here. So the OSPF neighbor was missing. It says the OSPF hello timer mismatch on leaf 2 prevents the adjacency. Boom, boom, boom. That's what we see. It's 95% confident that that's what our problem is, okay? Again, you can come down here, see the entire analysis as to why it believes that. And then this time we have a couple of things. Okay, this is where it's cool, I think. So remember, we put both faults in twice, right? But we didn't put them at the same time, so you know the system's like, okay, one came in after the other. But because by the time I went into the other and started my loop, the other agent or the other error had already been caught. And if we notice here, it tells us that there actually are both errors we can fix right here, right now. So the first one, which is the wrong IP address, tells us that it is this, the 10.99 or whatever, but it should be 10.0.1 to match leaf 1's. So that's our first error. And then our second error is the OSPF hello dead timer issue. So from right here, we can go and approve. All right, so that one's approved. All right, and this is what we're changing it to. Okay. And then we do this one. Approved. Okay. Now I want to just see this. Okay, now see, this is another parsing thing that I have to figure out because like I said, it's not a one-for-one transfer of how Nokia and FRR, whatever, how they handle their commands. So that's on me. So it tried to run a command that it couldn't run, and it tells you that it failed. So again, the agent is doing what it's supposed to do on that front because it's not going to go and try and make up some information from something that it can't pull. So that's good there. So we've gone ahead and we've set up the approvals for the fixes. And as you see, now the alerts are gone and your network is good to go. Now, I wish I would have done this. We also have reconciliation. You know what? I'm going to do this real quick in real time. Let me do another one just to show you guys. I'm going to just give it the same error. Shut down the BGP neighbor 10.100.0.1 on leaf 3 to simulate a peering failure. Okay, I'm going to shut that down again, and then I'm going to run a reconciliation. This is basically going to help us detect drift. Give me a second. Claude's like, you already shut it down, so why are you trying to do it again? All right. Because I want to do it again, that's why. Okay, I'm fighting with Claude, so bear with me just a second. I messed up some. Let's run the test for fault 1 again, please. Okay, so while it re-injects my fault, let's go here and talk about the audit trail again. Now, like I said, this is an immutable trail that shows everything that the agent does and agent touches. And again, I got to shout out John Capobianco. Great job doing this. I mean, it's pretty cool. So basically what we've done, so this, we took our session here, and this is the one for the dead timer, right? So it basically shows that, when the session starts, and it will show you when it does tool calls, it captures state, pre-change state. It goes through, it captures post-change state and post-change validation all on leaf 2, okay? And you can go down and see these logs for everything that it touches. So in this one, the OSPF neighbor count was 1, it was below the expected 2. So it shows you when it starts, the reasoning phase, it shows you all the tool calls, the results, it comes back, gives you the reasoning, it comes back, it logs its decision and its confidence in the decision, as well as it shows the proposed fixes all the way down. Remember those errors that I told you about, that it couldn't log into the device, or the commands were wrong? It captured those. And basically, this is that entire flow. So shout out, like I said, to John for bringing that in. And let's see, is this thing working? Oh, okay, I'm sorry. This is why I like doing these things live, because no matter how many times you practice, something can always go wrong. So that's just kind of what Claude's doing. He's confused of why I'm asking him to break my network still for whatever reason. Here we go. Okay. And this is all I just wanted to show. So now we have some errors coming in. And if we go to drift here and we just run a quick reconciliation, and of course you can flesh it out more after it's done, but it runs a reconciliation. Now it's checking netbox, it's checking the YAML, the intended state of the network, to then tell you, hey, something's gone wrong. Spine 2, the description says it's the OSPF neighbor count is 3, below the expected 4. And it gives you all this stuff. So this is just another way that you can represent that data. So I'm not going to go back and clear it. We've seen how it works. I just wanted to come on and show you all that the agent is working. Is it perfect? I wouldn't say it's perfect. There's a lot more that I could add to it. A lot more of the logic underneath, still thinking that through, getting some of the coding figured out. But as far as being able to say, are agents going to be able to live in our networking devices and help monitor our networks? Eventually, I think that time is coming. The more that we secure these things and the more that we're able to harness them and put guardrails around them. And I'm a big human in the loop person, so I will never say that a human should not be involved in touching a network. I understand the need and the want to have everything run autonomously, but just, maybe it's just the network engineer in me that always just want to humanize on it. So that's why I built in the human in the loop aspects to the agent. And, I think this is definitely a great first start. So this is my attempt, guys. This is, what I've been building towards as far as, it started out with just getting my Kubernetes cluster set up. And there's even some things on that I'll probably change, probably shifting over and getting away from Nginx and just doing everything through Cilium, and those are some things I'm thinking about, but that's for another decision on another day. I just wanted to, thank everyone that's been following, thank everyone that's been commenting, giving me some encouragement to keep going with these labs and with things like this. A lot is moving fast. And as network engineers, this really isn't our forte as far as delving into software and, having to learn APIs, front end, back end, all that stuff can be a little bit daunting. But, my goal is to help everyone kind of just, see that the transition is possible, give you guys some ideas and some tools to help you make that transition. So go to my website, www.thetech-e.com. Go to my GitHub, it's e-Connors Lab on GitHub. I've got a lot of projects there that'll help you get into network automation. I'll go ahead and say this project I'm not going to open source yet. Like I said, I still have a lot of things that I want to do with it. But I will be open to the right opportunities to possibly collaborate and, share the project and, do some other big things with it. So I appreciate you guys taking your time to stick with me and watch this video and see how far we've come. We've got some more cool things to come along. And, I just thank everyone for your time. And if you like this video, hit the like button, subscribe to my channel. Share the video, let everyone know. If you're in a network engineer or in the AI space, let everyone know, hey, there's a guy out here who's trying to do some cool things with agents and yada, yada, yada. Hey, I'm not super formal, so just come and just, hit me up. I'm on LinkedIn all the time. You can find me at Elliot Connor on LinkedIn. So I hope you guys enjoy it, and I'll catch you in the next one. See you soon.